All right, guys. So after bell work, I want to make sure that you've read this FYI. There is a link after you press submit. I want you to read this first and answer the 2 questions that are down here at the bottom. I want you to answer those in the next 2 boxes. Here we have an explanation of how we get our zodiac signs. So we have Earth, and as the year progresses, the sun does not move around the Earth. This is just a representation of where the sun would be compared to the Earth. And whichever set of stars is on the other side of the sun, that's what sign it is. So I am in August, and in August, the set of stars that's on the other side of the sun is Leo. You're in May, set of stars on the other side. The end of May is Taurus, the beginning of May is Aries. Our North Star. How do you find it? There's 2 ways. And the first way is to use the pointer stars at the end of the Big Dipper. The Big Dipper is very easy to find and easy to see, for most people anyway. So you're going to take the 2 stars that make up the end of the pot on the Big Dipper, and they're going to point directly to Polaris, which is our North Star. It's called Polaris because it's directly above our North Pole. You can also find the Little Dipper, and it is the last star that's in the handle of the Little Dipper. So find the 2 stars on the Big Dipper that make up the end of the pot, and we'll point to Polaris. The other way is to look north. I'm going to jump into the screen here. Hopefully you can see me. Let's say that north is this way. You're going to look north, and you're going to figure out what your latitude is above the equator. Here in Orlando, it's about 28 degrees. We are at about 28 degrees latitude between 0 at the equator and 90 at the North Pole. So I'm going to find the horizon, and I'm going to use my arm as though it was a protractor, and make an angle that is 28 degrees. And if I'm pointed directly north, then that means that I am pointing my finger at the North Star. Let's say I was up at my grandparents' house in northern Michigan. They are at a latitude of 45 degrees. So I'm going to find the horizon, make my arm into a protractor, try not to look like a Nazi. I'm going to point my hand up 45 degrees if I'm facing north, and that is going to be the North Star right where my finger is pointing. New York is about 41 degrees latitude, which means you would make a little angle of 41 degrees. So here's 0, that's 90. 41 degrees is going to be about right there, a little less than halfway. At the North Pole, you have a latitude of 90. So to point to the North Star, if you're standing at the North Pole, you would have to be at 90 degrees. You'd have to point directly over your head, which makes sense because if you're at the North Pole, the pole star should be directly over your head. At the equator is at 0 degrees, so you go 0 degrees and don't move your finger at all. If you're pointed directly north, you're going to be pointing at the North Star right at the horizon. As you travel north and get higher and higher latitudes, obviously you're going to have to move your finger farther and farther and farther up until you get to the North Pole. In the southern hemisphere, in order to point to the North Star, you start at the horizon, you actually had to move down. You'd be pointed at the ground. Because being in the southern hemisphere means that the North Star is on the other side of the planet. You'd have to point through planet Earth. Let's go back and use that first one. Use the pointer stars of the Big Dipper. So these two stars are going to point to the North Star. See if you guys can find the Big Dipper. It's right here. There is the bucket of the Big Dipper. Use these two stars, and there is our North Star. So you have the handle, the bucket, pointer stars. That's going to be the North Star. And if you look, this is the handle of the Little Dipper. So pointer stars. There we go. So as time goes on and the Earth rotates, the stars are going to seem to move through our sky. That's happening because the Earth is rotating. But the North Star being directly above, the Earth is just spinning right underneath it. So our North Star seems to stand still while all of the other stars move. Our North Star, is that directly above our solar system? If it's directly above planet Earth, wouldn't it make sense that it's also directly above Mars and directly above the Sun? Well, no, because Earth is tilted. So it is directly above the axis of planet Earth, but because planet Earth is tilted, it's not directly above our solar system. You don't go directly up. It also means that you can take a lot of really neat pictures. Polaris is actually what's called a binary star system. There's Polaris A, Polaris B. It's a little white dwarf that we didn't even know about until we got some infrared telescopes sent up into space. But if you take a camera, put it on a tripod, and have a long exposure, you can actually see the stars as they travel through the night sky. Except for one, except for our North Star. These make for, in my opinion, some of the coolest photographs. You'll notice that as the latitude of the place where they were taken goes up, the North Star is going to get higher and higher in the night sky. So this is in Hawaii, which is pretty close to the equator. Now we go to Iran, Massachusetts, which is a little bit farther north, and Alaska, where the North Star is getting to be almost directly overhead. Normally I have people guess what city this was taken in. If you take a look, it's actually about halfway up the sky between horizon directly overhead, which means it's at a latitude of about 45. This is actually taken in Paris, France. This is a time lapse, a number of photographs that were stitched together to make almost like a little movie. Let's see if you guys can figure out which star is Polaris. There's really no way for me to test you on that, but I do want you to be able to figure out which star is Polaris. I'll tell you, it is that one. And how do I know? Because that is the only star that, as the Earth is rotating on its axis, does not appear to move. So here's a question for you. Constellations appear to move across the sky at night because? I want to know your answer. the Earth spins on its axis. Right now, our North Star is directly above the North Pole. But I mentioned the other day that our Earth wobbles, which means our axis does not always point in the same direction. It takes 26,000 years to wobble one time, so it actually goes pretty slow. This is not something that any of us will have to worry about in our lifetime, but something to be aware of, that thousands of years in the future, our axis is going to be pointed at another star. So right now, Polaris is in the constellation of Ursa Minor, but in about 3,000 years, the Earth will wobble, and Iota, which is in the constellation of Cepheus, so it's called Iota Cephei, they're labeled as far as brightness. So Alpha Cephei would be the brightest star in that constellation, Beta, Gamma, Delta, Epsilon. So Iota Cephei, the Earth is going to wobble, and in about 3,000 years, that is our new North Star. The Earth is going to continue to wobble, though, and it was pointed there, now it's pointed there, now it's going to move down a little bit farther, out of the Cephei, the constellation Cepheus, down into Cygnus the Swan. You guys can tell that's a swan, right? Doesn't look like a plus sign or a cross. It definitely a swan. But in the year 10,000, Deneb, which is one of the brightest stars in this entire constellation, is going to be our new North Star. Luckily, though, it wobbles, which means the axis is going to start going back. And in the year 27,800, Polaris is going to be our North Star again. If I showed you this on a test, would you be able to figure out which star is the North Star? Here is the Big Dipper. Use the 2 pointer stars. That is the North Star right there. Now what I would like you guys to do, there are 8 star charts. I would like you guys to choose one, your choice, download it to your computer, and then open it up in Microsoft Paint. And it's going to be your job to create your own constellation. It says to glue it into your science journal, however, you can't turn it in if you do that. So you're going to download this and open it up in Microsoft Paint. Once you've done that, you guys are going to connect dots to create a constellation. It could be whatever picture or object or person you want it to be. And then I want you to come up with one paragraph telling me the story of your constellation. The other day I mentioned how the Pleiades, or the Seven Sisters, had that story where they ran up a mountain and they were flung into the sky to escape their dad who was chasing them. You guys are going to create your own mythology behind your constellation. You're going to turn that in on Canvas. Keep in mind that most constellations do not look like what they're supposed to look like. I don't even know what most of those are supposed to be. There is one exception. Triangulum, the best constellation of them all, looks exactly like what it's supposed to look like. Other than that, no clue. Also keep in mind that they are not an outline. So Ursa Major, it's almost as though the stars are creating the bear's skeleton. For Cassiopeia, I don't know how they got that. But it is not an outline of her body. For Libra, again, I'm not sure, but yeah. Maybe some of them kind of sort of look, maybe this looks like a hunter. There's a shield, a club, a belt, the shoulders. I don't know if that's his ankle or his foot. Leo, you have a head and a body and a tail and feet, so maybe it kind of looks like it, but it's not a connect the dots. It's more like these are the inside of whatever picture it is that it's trying to represent. So don't do a connect the dots picture. It shouldn't be an outline. Put the stars on the inside and then do a rough sketch around the outside. That is due tomorrow at midnight.